So, you want to get certified in cybersecurity? I will help you every step of the way. Welcome! In this session, we'll explore in detail how to safeguard your data in the cloud using a combination of robust protection and encryption methods. Understanding these techniques is crucial for maintaining the confidentiality, integrity, and availability of your information in today's cloud-centric world. Data is undeniably a valuable asset, often considered the lifeblood of any organization. Its protection is therefore paramount. In the cloud, data protection goes beyond traditional security measures. It involves a comprehensive strategy to ensure confidentiality, preventing unauthorized disclosure, integrity, guaranteeing data accuracy and reliability, and availability, ensuring that data is accessible to authorized users when needed. This holistic approach necessitates protecting data at every stage: at rest, while it's stored; in transit, as it moves across networks; and in use, while it's being processed. To achieve this comprehensive data protection, various methods can be employed. We've previously discussed access control, which plays a vital role in limiting who can access data in the first place. In addition to that, we first have data loss prevention, DLP. DLP is a set of technologies and practices designed to detect and prevent sensitive data from leaving the organization's control. This includes monitoring data in use, in motion, and at rest to ensure that confidential information isn't accidentally or maliciously leaked. And second, we have backup and recovery. This is another critical aspect, ensuring that data can be reliably restored after any incident, whether it's a hardware failure, a natural disaster, or a cyber attack. Robust backup and recovery plans are essential for business continuity and minimizing data loss. Now, let's delve into one of the most fundamental data protection methods: encryption. Encryption is the process of converting data into an unreadable format, known as ciphertext. This effectively protects the data from unauthorized access, as even if someone intercepts or gains access to the storage medium, they won't be able to decipher the information without the correct key. Only those possessing the decryption key can convert the ciphertext back into its original, readable form called plaintext. Encryption is a cornerstone of modern data security, especially in the cloud, where data traverses networks and resides in shared environments. There are two primary types of encryption, each with its own strengths and use cases. First, symmetric encryption. In symmetric encryption, the same secret key is used for both the encryption and decryption processes. This method is generally faster and more efficient, making it suitable for encrypting large amounts of data. However, the challenge lies in securely distributing the shared key to all authorized parties. Second, asymmetric encryption. Asymmetric encryption, also known as public key cryptography, employs a pair of keys, a public key and a private key. The public key can be freely distributed and is used for encryption, while the private key is kept secret and is used for decryption. This solves the key distribution problem of symmetric encryption, but it's typically slower and more computationally intensive. Asymmetric encryption is often used for key exchange and digital signatures. Cloud providers offer a range of encryption options to help you secure your data. First, encryption at rest. This involves encrypting data while it's stored on cloud storage devices. This ensures that even if the storage is compromised, the data remains unreadable. Second, encryption in transit. This protects data while it's being transmitted over networks, such as when you're uploading or downloading files or accessing cloud applications. Common protocols like HTTPS and TLS provide encryption in transit. Third, bring your own key, BYOK. This option gives you more control over your encryption keys. Instead of the cloud provider managing the keys, you generate and manage them yourself, and then import them into the cloud environment. This can enhance security and help meet specific compliance requirements. To maximize the effectiveness of encryption and ensure robust data protection, it's essential to follow these best practices. 1. Use strong encryption algorithms. Choose industry-standard, well-vetted encryption algorithms like AES for symmetric encryption and RSA or ECC for asymmetric encryption. Avoid using outdated or weak algorithms. 2. Implement proper key management. Securely store and manage your encryption keys. This includes controlling access to keys, protecting them from unauthorized disclosure, and establishing a key lifecycle management process. 3. Regularly rotate encryption keys. Periodically changing your encryption keys reduces the risk of compromise. The frequency of rotation should be determined based on the sensitivity of the data and the potential threat level. 4. Comply with relevant regulations. Ensure that your encryption practices comply with all applicable data protection regulations, such as GDPR, HIPAA, and PCI DSS. And that concludes our video. In our next lesson, we'll cover network security for cloud deployments. Be sure to check it out. For more valuable content, come visit our website, securetechacademy.com. Sign up for our newsletter and explore our premium courses on Udemy, designed with you in mind, using the latest technology to be more engaging at a lower price. If you found this video helpful, be sure to like, subscribe, and leave a comment if you have any questions. Thanks for watching, and I will see you in the next one.